After selecting an appropriate water sources, the next step is the process of accessing the source for conveyance to the water system. In this picture, we see an unprotected lake water intake in Iran with abstraction by diesel-powered pumps. Since intake and abstraction technologies work so closely together, we'll examine them together in this module as well. After watching this module, you'll understand the roles of intake and abstractional functional groups within the overall water supply system. You'll also recognize the working principles and applicability of different intakes, pumps, and energy sources, and be able to assess the advantages and disadvantages for a few examples of these technologies. Intake refers to the point where water is withdrawn from the source, while abstraction entails the physical removal and transport of the raw water using some energy source. We'll first have a look at two selected intake technologies, namely roof water collection and protected spring, and then introduce the deep well piston pump and the hydraulic ram pump as example technologies from the functional group abstraction. You can find more information on these and other intake and abstraction technologies in the Water Compendium. Starting with roof water collection, this is a very flexible system that can supplement a household's existing water supplies at certain times of the year. Rainwater can be collected through a gutter on the rooftop or using a tarp system as shown here, and then stored at a household level in a rainwater tank. Rainwater collection has several advantages, including very low capital and operational cost with no external energy inputs required. As a self-supply system, rainwater harvesting structures need only minimal ongoing maintenance. However, the quality of the collected rainwater depends closely on the harvesting method. For example, the roof can introduce contaminants like bird droppings and air particulates if the first flush is not diverted away from the storage tank. There's also the chance of contamination and algal growth within the rainwater tank itself. And during dry seasons or drought, the system may not be used. Overall, rainwater is a good option for supplementing existing water sources if at least 300 mm of rainfall per year is available. Now, let's take a look at a protected spring intake, which facilitates the collection of spring water and also protects it from surrounding contaminants. Depending on the type of spring, the intake structure can vary. In this illustration, the spring intake consists of a concrete spring chamber with one permeable side to allow the spring water to enter by gravity flow. The supply or outlet pipe delivers water to the system downstream and an overflow pipe with a screen to prevent insects and small animals from entering discharges any excess water. A minimum protection zone of 15 meters radius is recommended, along with a diversion ditch uphill from the spring intake to shield it from pollution and also from erosion. Looking at the advantages and disadvantages of this technology, spring intakes are simple and robust, but also low cost compared to other intake technologies. It can be constructed from local materials and has a highly adaptable design. However, there may be water flow variability depending on the type of spring, and it may not always be sufficient to meet water users' need throughout the year. In addition, this intake technology may be prone to erosion issues as it is usually located on a slope. Now, let's look at abstraction technologies and energy sources required for physical transport of raw water from the source to treatment plants' storage, starting with deep well piston pump. Deep well piston pumps are a type of positive displacement pump that moves a fixed amount of water per cycle. These pumps are unique in that water is lifted from deeper depths with the help of a lever as shown in the illustration. This is a commonly used abstraction technology, especially in the areas dependent on communal water points with deep water tables beyond the reach of other types of pumps. Deep well piston pumps are usually equipped with hand pumps, which are extensively found throughout Asia and Africa. Hand pumps are manually operated, and transport of the pumped water to the home also requires human energy. The main advantages of this abstraction arrangement are that it's capable of accessing deep aquifers that might otherwise remain inaccessible, and water from deep wells is generally free from microbial contamination. However, there are several disadvantages too. Human-powered hand pumps come with an intensive time and labor burden, which also presents a risk of injury or exertion. These burdens are mainly borne by women and girls who are typically responsible for fetching water in their communities. Especially for hand pumps located off household plot, it may be difficult to collect sufficient water to meet all the household's domestic and productive needs. And finally, deep well piston pumps are very prone to mechanical failures due to higher lifting forces, and the design complexity requires greater operation and maintenance. Our last example of an abstraction technology is the impulse or hydraulic ram pump, which is designed to provide pressurized water supply with little or no electricity or fuel input. Hydraulic ram pumps use the velocity of an existing river or a stream and a difference in height to create a pressurized flow. As shown in this illustration, the pump is located at a lower level and uses a series of one-way valves and a compressible pocket of air to harness the energy of the flowing water. These pumps are commonly used in hilly or mountainous regions where there is sufficient capacity to both drive the pump and fill the elevated tank. Since hydraulic ram pumps run on a renewable hydropower, there is little to no need for other energy inputs such as electricity or fuel. They can operate for 24 hours per day, 7 days a week, for many years with little maintenance as long as there is sufficient flow to drive its operation. They are robust due to having few moving parts and relatively easy to maintain under local conditions. The main disadvantages of hydraulic ram pumps are that they can only be used where there is a natural elevation difference of at least 1 meter between the water source and pump position, and in most cases, volume outputs are low, typically in the range of 1 to 3 liters per second. To sum up, intake and abstraction technologies make up the second and the third functional groups of water supply systems respectively. Using a few intake and abstraction technologies as examples, we looked at their working principles, applicability, energy requirements, and various advantages and disadvantages of each.